I want to take up the organic reactions quiz. And with the organic reaction quiz, thorough understanding of the flowchart of reactions would help you to have done well and help you to understand what's going on. So our first reaction is a reaction between a benzene and an acyl halide. And we know that these reactions, this will be a substitution reaction where my acyl group will substitute one of the hydrogens on the benzene. For this reaction to occur, we need a catalyst of aluminum chloride or iron 3 chloride. But when that happens, one of my hydrogens on my benzene will be replaced with the acyl group. The hydrogen that comes off will combine with the halogen to form an acid. For the second reaction, we have 4-methyl pent-10-2-one, and it's going to react with a reducing agent. Right? And so if we look at our flow chart, we know that since this is a ketone, we know that ketones are formed by the oxidation of a secondary alcohol, and their reverse reaction, which would be a reduction reaction, involves, so the reduction of a ketone will give me a alcohol. So since it would give me a secondary alcohol, remember reduction, the double bond is going to be broken. So I'm going to have a single bond, and I'm going to have a hydrogen and a hydrogen. I increase my number of bonds to hydrogen, decrease my number of bonds to oxygen. And so we'll get this as our product. Our third reaction is a substitution reaction. Here I have an alkane. We know this by all single bonds, and I'm going to react that with a halogen. So if we go to our flow chart, we can see, hey, an alkane is here, and I want to go to halogen. It's a substitution reaction, and we may remember that for this reaction, I need a catalyst often, but most importantly, I need UV light or heat for this reaction to occur, to be able to go from an alkane to an acyl halide. So therefore, I need my UV light or heat as my catalyst. And when that occurs, what happens is that one of the hydrogens on my alkane will be replaced with the bromine. And then the hydrogen that's replaced will combine with the other bromine to form my hydrogen bromide, hydrogen monobromide or hydrobromic acid, depending on the conditions of the reaction. Our next reaction involved the reaction of this molecule, and even if we didn't know the exact reaction, since we're reacting with water, that tells us that it's going to be a hydrolysis reaction. So if we go to our flow chart, in our flow chart, we can have one hydrolysis reaction occur here, where I break down my ester back into the two alcohols. So the question is this molecule an ester? Or I can have hydrolysis reactions occur here, where I have an amide or an ester. Sorry, this is an ether over here. Okay, and so the question is, which one is it? So if I look here, I can see that I have a nitrogen. So I have a carbon bonded to a nitrogen, bonded to a carbon that's double bonded to an oxygen. So therefore, this tells me that it's an amide. So therefore, I know that I'm at an amide here, and I have to go back to a carboxylic acid. And so for this reaction, we need heat, because we have to break a bond. And then we need either a strong acid or strong base. For this to occur. Okay, now usually we use a strong base, but we'll use a strong acid this time. And when that happens, this bond between the nitrogen and the carbonyl will break. The nitrogen will need another bond, so the hydrogen from the water will bond to it. And then the carbon, now this carbon that will be left, will need another bond as well, so the hydroxyl group in the water will bond to it, and this will take me back to my component parts that formed my amide. So now I can see my carboxylic acid and my amine that resulted in the formation of this amide. And so the hydrolysis reaction would be the breakdown of it. The next reaction on the quiz said that we wanted to form pentanetone, and it said that we were going to form it from our 1-pentene. And so the question is, how do I go from there to there? Well, if we come to our flowchart, and our flowchart will help us, my 1-pentene is an alkene, my 2-pentanone is a ketone. So I want to go from here to there. And there's no direct connection, so that means I have to go through the flowchart. And I start here. The shortest route is for me to become an alcohol, and then me to become a ketone. So therefore, to become an alcohol, my alkene has to go through an addition reaction. When it goes through addition reaction with water, it'll form an alcohol, and my alcohol can undergo an oxidation reaction to become a ketone. So therefore, I'm going to take my compound, and I'm going to have it undergo an addition reaction. We're going to have water added onto it. Okay, again, this reaction requires heat and a catalyst. Now, when this reaction takes place, because this is an unbalanced alkene, and what I mean by that is that the number of hydrogens on the two carbons involved in a double bond are different, I'm going to get two different products. I can get my OH group on my first carbon, or I can get it on the second carbon. And so to know which one is my major and which one's my minor, we go to Markovnikov's rule. It tells me that the hydrogen-rich carbon is most likely to get the hydrogen. So this carbon has two hydrogens already. This one only has one. This carbon is more likely to get the hydrogen. So this is my major product, because this is the carbon that has more hydrogen, and we're putting the hydroxyl group on it. This would be my minor product. So in this reaction, I would first do an addition reaction, and then I would take the major product of this reaction, and I would have it undergo a second reaction with an oxidizing agent. And so I'd take this and I'd react it with an oxidizing agent, and this would give me my ketone. So I take my major, react it with an oxidizing agent, and this gives me my ketone.